We are now going to start talking about how to calculate the tension and compression in the different beams. If you did not pick up the first video, that is where we determined what the reactionary forces are, the 50, the 125, and the 225, and the directionality of those. If you do not know how to calculate those, you need to go back to video number 1. So in order to calculate the different tension and compressions, we are going to look at the different beams, the different points in terms of nodes. So we are going to do free body diagrams for each one of the different joints that we have. The easiest joint to work with probably would be to start with E. Which is where I am going to start. So we look at E, and we have 3 different things happening at E. We've got this 50 coming down. We have a diagonal element that is coming down this way, and then we have a horizontal element. So the formula is always the sum of all forces with respect to x at E, or at E, with respect to x must equal 0. And then we are also going to look at the fact that the sum of all forces at E with respect to y equals 0. So at the end of this member we have D, at the end of this member we have C. We know that this is a 45-degree angle. So let's see what our 2 different equations end up looking like. So in terms of x, both CE and DE have x components. CE is a horizontal beam, and therefore the entire force is horizontal. So for CE, we have F of CE. We don't need to incorporate the x there because there is no angle. It is purely horizontal. But for ED, we have the force of DE with respect to x. So that is F of CE plus, now the force of DE with respect to x is the overall force of DE multiplied by, since we are using x, we are going to multiply that by the cosine of the angle that that force is being applied at. And we know that those 2 forces together, that is all of our horizontal, is going to equal 0. Now, we have to stop there because we have 2 different unknown values in one equation. And so we can't actually calculate the x yet. But if we look at the y, we see things are a little bit different. In terms of the y, we only have one unknown. Our sum of y's, now what y's do we have? We have this 50, and it's coming down, so that would be a negative 50. And then we have whatever this is. So that's going to be f of d e y. Those are the only 2 vertical forces that are at point E, and so we know that the sum of those 2 equals 0. F of DEY is the overall force at DE, which is what we are trying to solve for, multiplied, since we are now talking about y, we multiply that by the sine at the angle which that force is being applied, which in this case is 45. I'm going to take that 50 and move it to the other side. So that would be F of DE sine 45 equals 50. So F of DE equals 50 divided by the sine of 45. And F of DE, putting that in the calculator, F of DE equals 70.71. Now, we did this calculation using y. that's positive. So as our arrow travels along this diagonal, it needs to be going up because the y is positive. So the arrow coming into E is going to be going that way. Now I'm going to switch over to here. And so I'm bringing this arrow into E that way. Then we know that we always have the opposite arrow going into the member. And that's where that 70.71 comes from. And then that's going to push in because that's opposite that arrow. And then that's going to push out that way. And because the two arrows in the member are facing towards each other, that is a push in, and that is compression. So we now know that the overall force that C is under is 70.71. At this point, we can now go back to our X calculation. So I'm going to erase this bottom piece that I just did in terms of Y since we're done with it. Now I have f of CE still in this equation that we were working on before. We had the f of CE plus f of DE, which we now know is 70.71. And since it is going, now we're working with x, since that arrow is going to the right, right? Since it's pointing that way, that's pointing in the positive direction. So that 70.71 is positive, times the cosine of 45 equals 0. So f of CE is going to be negative 70.71 times the cosine of 45. And I plug that in the calculator, and we get -50. -50. So here, all right, we are working in X. That's -50. So at my node, it's negative, so it's pointing away from the node in the negative direction. In the member, it's pointing back that way. So we have 50. Putting in all my little arrows, and since that 50 has arrows going away from it, that is going to be 50 tension. So we have calculated both of those in terms of using node E. We are now done with node E, and we are ready to move on to one of the other nodes. So let's do that. Alright, so I'm going to move on and do node D as my next node. D. And when you're working these problems on your own, you just got to check and do the diagram and see if you have enough information to work from that node. If you find you don't, you can always switch nodes and come back to it at a later time. Anyway, node D has a vertical node that goes up to C. We don't know anything about that force yet. It's got a horizontal node that's coming from A. We don't know anything about that node yet. It's got a force of 100 that is coming in purely horizontally. And then we have a vertical force that's coming in that we calculated from there. And that is going to be 70.71. So now we're going to do the same type same type of calculation we did at our last node. We know the sum of all forces with respect at D with respect to X must equal 0. And so AD is purely horizontal, so that would be the force of AD plus we have this 100 that's coming to the left. It's pointing that way, so it's pointing negative. And then we also have the force of DE with respect to X equaling 0. inputting the information about DE. So let's say we have FAD minus 100. Now, DE with respect to X, since it's coming down in this way, doesn't matter that it's coming down, but since this arrow is going to the left, that makes it negative. And it is F of DE, which we know is 70.71. And then since we're working with X, that's going to be cosine 45. And all of that equals 0. So F of AD, adding 100, adding 70.71 cosine 45 to both sides. I plug that in my calculator, and we get positive 150. So it's positive. That means it's going in this direction. When I go up here to add the information in, I'm going to go ahead and get rid of that angle, even if I need it later. We know that angle was 33.69. Write that down there so I can use it later. But so I can fit this in. So I've got this 150 that goes there. Like we said, it's positive, so it's pushing into D. Opposite arrows. So that 150, since the arrows are pointing towards it, that is 150 in compression. Let's quickly get that Y down. I'm going to run out of video time and have to switch videos for the next node. That's okay. The sum of FDY equals 0. So we have two Y's. We have whatever's happening at CD. F of CD. And again, I just left it as F of CD because it is pure vertical. Plus, we also have the FDEY. Those are the only two vertical forces that are at work at node D. F of CD plus F of DE is 70.71. It is coming in down, so it is negative. F of DE is 70.71. Since we are talking about Y, we say sine 45. So F of CD will be $50. And it is positive 50. So when we go to input that, that's going to be up 50. So those arrows in the middle push away from each other. So that is 50 tension. Alright, I'm going to stop this video here and we will pick up moving along. We've still got 3 more members to calculate. We will calculate those last 3 members in the next video.